first of all, I want to thank the SLTC board for the invitation and the possibility to present our efforts in sustainable leather production here. I'm going to present our bioenergy recovery plant and the experience we gained with this process during the last almost a decade now. What are you going to hear today? I want to start with a short introduction of the company I'm representing here. I will later on explain the objectives of the project, lose a couple of words about design and function of the plant. I will line out our operational experience and finally end up with some perspectives of the whole project. Who is Südleder? Südleder is a German contract tenor. We're located in the, as I learned yesterday, village of Breau, which is a very small town in Bavaria, having about 10,000 inhabitants. For historical reasons, the company, as you can see here, is almost in the city center. And what is not in the center of the city is our wastewater treatment plant, which is located 2 kilometers outside the village. So that makes life a lot easier for us because all the smells are outside. We are producing mainly bovine hides for the automotive industry. Our main products are wet blue, wet white, and crust. But almost 70% end up being wet blue or wet white. Almost 30% are processed further into crust. Our daily capacity is about 3,000 to 3,500 hides a day, almost 6 days a week. We are having 270 employees. 7 of them are leather technicians. 1 of them graduated here in Northampton, so as to make a short tour around. The others still being very proud of having graduated in Reutlingen, which is a big problem for the German leather industry that Reutlingen doesn't exist anymore. What else do we have? We do have, in Germany, we do have an apprenticeship scheme, so you can learn to be a tanner. This is a 3-year experience, school-based apprenticeship, we call it. So we do every year have 2 or 3 of these tanners. Actually, would like to have 4 or 5, but unfortunately, tanning is not the job young people are very keen on. So we have to do some more advertisement to find them. That's what I wanted to tell about Südleder for the moment. As we are a contract tanner, we had to find a way to turn our tanning process more sustainable, to fulfill all the requirements, and we had a close look at what is around our process. We have customers with certain requirements, certainly from the automotive industry. We do have legislation, and last but not least, we do have the economy. And all that influences the tanning process, and we have to find out ways to find win-win situations. What do we put into the process? We have a lot of water. In our case, it's about 2,000 cubic meters every day. We have the hides, we have the additives. On the other end, we are producing wastes, not only solid residues, but wastewater as well. And we do need an awful amount of heat and power, electric power in this case. So we try to find a way to produce heat and power on ourselves from our organic residues. So just we have 2 advantages. We reduce our amount of waste and we get independent see the project itself, what the project should fulfill the following requirements. We have to remain flexible because we're a contract tenor and we depend on the wishes of our customers. Sometimes we have all red blue, sometimes it's more red white, sometimes it's salted, sometimes fresh height. So the system has to be flexible and has to be able to answer all these questions. As I told you, we wanted to get independent from external power providers and thus have more predictability in energy costs, because prices, I think it's the same here, have been rising and rising for energy. So it was unpredictable where they were going, and we wanted to figure out a fixed price which we can influence ourselves. Once more, we wanted to reduce the amount of disposable waste, and at the same time we wanted to reduce the CO2 emissions of the process. And we wanted an optimized energy recovery. All that points sustainability. We started off with fat recovery from our flashings. We have lime flashings, and what we do first, we cut them into pieces with 2 big cutters, and then we run them through a heat exchanger, which you can see on that side up there. The second step of this process is a decanting centrifuge. Actually, it's a three-canted centrifuge, because we separate the solid greaves from the fat and the water. We have to treat the water in our wastewater treatment plant because it contains a lot of sulfide, and we cannot dispose this off just like that. We have some nice storage tanks for the fat. This enables us to store about 60 cubic meters of fat, and we can either sell it or burn it in high-speed steam generators, which we newly built up in 2006. By this project, we reduced our carbon dioxide emissions about 4,500 tons a year, calculated as burn fat. So that wasn't enough. 4,500 tons, it's quite a number, but we wanted more, and we tried to find out other ways to reduce the waste. Flashings are reduced by this process of fat generations to about a third of the original amount. So which waste streams can we use for energy productions? What you can see on the right-hand side is the production of fat. Fat is shown as the yellow line to be burned in the high-speed steam generator and then provide heat for production and fat recovery. On the other hand, we have the wastewater stream, which is going to the wastewater treatment plant, as I said, 2 kilometers outside the village. There we have chemical physical pre-treatment, which is flocculation, precipitation with ferrochloride and a bit of lime. In the beginning, we put this into the sludge rising there in the thickener, and then it was dewattered and disposed of for incineration. There was an awful amount of sludge, and we wanted to reduce that. So we started a lot of trials with converting the sludge anaerobically. We started off with little penicillin flasks, 100 milliliters each. That were the first trials I did when I came to Südleder almost 20 years ago. It was quite successful already at the beginning, but at that time nobody wanted to build a biogas plant because it was not sophisticated enough, the process for industrial biogas plants. In 2005 we started a laboratory scale fermenter, which you can see on the right. This one's got 20 liters of volume, and we fed it every day with a new sludge from the wastewater treatment plant, so that we could find out if the process was stable with changing qualities of the sludge. And then there was a big question mark: do we do a small scale up or do we build a biogas plant? Calculating a small scale up for about hundreds of cubic meters didn't really make sense. A 1 cubic meter scale up really doesn't make sense because our final plant has 8,000 cubic meters of volume in the fermenters. So we figured out that we thought we would just build the whole scale plant. That cost us a couple of sleepless nights, but okay, finally it turned out working. So our biogas plant consists of 2 holding tanks, one for the sludge and one for the grease from the fat recovery. Then the material is put into 2 digesters, and we build a biogas container. As the 2 digesters have a volume of 4,000 cubic meters each, and the biogas tank has a volume of 2,000 cubic meters. So it's quite a large plant. You can see here. And if you can see the small blue lorry on the right hand, you can see approximately the size of it. We had to build the whole plant into a basin just to fill the 4,000 cubic meters in case one of the fermenters would break down. In front you can see with the light green, it's a storage tanks for the substrates. And in the back there's a gas tank. So now we are producing gas, but we have to use the gas to turn it into energy, and that makes the scheme even more complicated. So we built a combined heat and power unit on the premises of the wastewater treatment plant. This is a small one, having an energy of 190 kilowatts, which provides heat for the digesters and even for the buildings for the people working. And then it provides electrical energy enough to run the whole plant, including the wastewater treatment. And we even have a small amount of excess electricity down there. The main part of the gas is sent back in a pipeline to the premises of the tanning process, and there we have 2 more central combined heat and power units. Each of them have a capacity of 630 kilowatts per hour, which provides the whole heat for the tanning process and the complete electrical power for the company. So we have reached the aim that we are energetically independent. Just to give you an impression of the combined power units, each of them is located in such a container. This is mainly because of, in Germany we call it Brandschutz, fire security or something like that. Must be in English. We have to remove it from the factory. And once these lovely red buildings had been ready, interest in this project arose even in the village. There are some more companies located close by, And they thought it would be a good idea if they could use some biogas as well. Unfortunately, we do not produce enough biogas to sell it, so we had to find another way. And we decided to open our microgas net for third-party users, which means we allow the other companies to take gas from the pipeline to run their own combined heat and power units, and we allow another company, which we own ourselves as well, not only we, but it's combined, where we use reviews from the inhabitants of the village. You know, all the organic residues they have, we put into another biogas plant, which is going to start the real production in July of this year. This is a scheme of the other plant we built there. So this is just for the reminders of the German braune Tonne. Okay, now we finally get to the operational experience of our plant. As you can see in here, we started with the sludge from the wastewater treatment without the greaves. The blue line is the sludge and the red line are the greaves from the fat recovery. And we could run the biogas plant in a stable way quite fast. So we already in May 13, we started in January 13, and already in May 13 we started to feed the greaves, which do quite a boost in biogas production because they still contain quite a lot of fat and a good part of peptides and things like that can easily be converted into biogas. Something we are quite proud of is the gas quality. Our biogas contains about 72 to 74% of methane, which is quite high and which is due to the fat content of the material. So this sheet is showing our monthly biogas production, which is quite dependent on how much leather we produce logically. So in 2013 we had to reduce the feed because we only had one big combined heat processing unit for the company, and we built the second one in December 2013. This chart is showing the reduction of the waste we have to dispose of. It's calculated the percentage of the material we put in the production. In the beginning we had about 33% of sludge and 25% of flashings arising from each ton of leather we processed. Without the fat generation we had no grease, which we call LOE. It doesn't mean low, but it's lime without water. So it's a German abbreviation. So with the beginning of the biogas plant in 2012, the dewatered sludge obviously reaches an amount of 0, but we do have the fermentation residue, which is shown in red, which finally ends up being 22% of the weight of the height. Overall, this reduces our waste at about 50% in some. So summing up, the 2 years of experience of our biogas plant have shown that we still are a flexible contract tenor who's able to fulfill the needs of its customers. We got one independence from external power providers, and we gained a new field because we provide energy. And finally, we will end up in providing energy for a school center nearby and even for some swimming pools. So even the village will take profit from our efforts. We do have predictable energy costs. We reached the reduction of disposable waste, which will never be finished actually, because every kilogram of waste is too much, so we are working on reducing it further. With the biogas plant, we reduced the CO2 emissions summed up as 10,000 tons a year. As I told you already, optimizing energy recovery is not finished yet. We're looking for some more residues we can put into the fermentation process, and we are hardly working hard on taking more biogas from the process. We reached a certain degree of sustainability. So, and as I told you before, we will have this organic waste plant, which will be officially put into operation in July of this month. This means if this plant will work properly, we can provide overall 40% of the energy the whole village needs, which is quite a lot. There's 3 big industrial companies are located in Real. One is Südleder, one is Lux. They are making window couples for caravans, and another one, which is quite well known, is called Real AG. They are doing water pipes and a big supplier for the automotive industry as well. This is not new, I talked about that before. So I'm coming to the end of my talk. I want to thank all partners involved, which contributed their part to bring this project to a successful milestone. I wouldn't say end, it's a milestone. And I want to thank all the colleagues who worked hard on the realization of the plan, especially to our director, Mr. Pöppel, who always supported us and pushed us further to get a step closer to the milestone. Last but not least, I want to thank the German authorities for funding our project. And I want to thank you for your attention. But I don't want to stop. I want to welcome you and invite you to take part on the VGCT conference, which takes place in Berlin on the 18th and 19th of June of this year. In case of interest, have a look at the homepage of the FILC or of the VGCT, where you can find the application forms. Thank you very much.